First on to, have scientists finally found evidence of the day the dinosaurs died?
Once upon a time, dinosaurs ruled the world. But 66 million years ago, they vanished virtually overnight. So what precisely happened in the minutes, the days, the weeks that wipes out 3/4 of the animal species on the planet? Many scientists now believe it was the impact of an asteroid that caused their extinction. But nobody has been able to prove it until now. Evolutionary biologist Ben Garrett and I have been granted exclusive access to a multi-million-pound drilling mission into the exact point where the asteroid hit.
This really is one of the most impressive science laboratories I've ever seen.
Could the team's findings about the asteroid finally solve the ultimate dinosaur mystery?
This is an absolutely amazing event. Mountains like the size of the Himalayas were formed in seconds.
With Ben at the impact site, I'll be travelling across the world to look for evidence of the events that followed. That is a bit of fossilised bone, and they're everywhere, scattered across this hillside. It's just extraordinary. Armed with astonishing new revelations.
Right here we have the smoking gun, and here we have the bodies.
We may finally be able to paint a picture of the demise of the dinosaurs.
I'm off the coast of Mexico right now, and this thing you can see behind me is a specially adapted drilling platform. Now there's an international team of scientists on board who are drilling far beneath the seabed where we are now to look for evidence to see why and how the dinosaurs died.
This is the exact spot of a huge asteroid strike that happened at precisely the same time the dinosaurs were wiped out. This is Earth, 66 million years ago.
Here's the asteroid. It's 9 miles across, the size of a city. And here's the first surprising thing, the speed of it. Now, it may not look that fast at this scale, but it was traveling at an unbelievable 40,000 miles an hour. Seen from the ground, it would have gone from a mere dot in the sky to impact in a matter of seconds.
The asteroid smashed into a shallow sea north of modern-day Mexico, exactly where the team is starting to drill. The theory goes that this impact set off a chain reaction of events that killed the dinosaurs.
But here's the heart of the mystery. When you compare the size of the asteroid and the Earth, well, the asteroid is comparatively small. It's like a grain of sand hitting a bowling ball. So how did this asteroid cause a mass extinction all around the globe?
By extracting rock from the impact crater, the team hopes to find out.
So I'm not even strapped in, and I don't especially like heights, but this is great. This is great.
This multi-million-pound operation has been decades in the planning, and we're the only film crew to have access.
Professor Joanna Morgan first proposed the operation.
It's been a long wait. I've been excited for, 16 years, so to actually for it to be happening is quite scary. I think we've had so much effort between us to get this to this point that you really want some lovely results.
Joining her on board to co-direct operations is Professor Sean Gullick.
So this is the ultimate test of some ideas, right? We have all these models about how the extinction happened, but without some samples from ground zero, we can't really test them.
This really is one of the most impressive science laboratories I've ever seen. And it's an amazing place. We'll have a quick look around. Now, this central area here is incredibly important. This is known as Main Street by the crew and scientists. Now, these shipping containers are actually science labs. And in each one, there's a whole entire laboratory. You can see in here huge amounts of equipment. This is one of the scanning labs. But there are still lots of personal touches. You can see where all the different scientists and the rest of the crew are from. Though my hometown's not on here.
But this is the star of the show. This huge drill will bore through 1.5 kilometers of solid rock, taking us back to the time of the dinosaurs.
This is the drill bit. Each one of these little nodules is an industrial diamond. We've had this one modified with a higher speed head that allows us to core.
We're literally collecting a column of rock 3 meters at a time, and as we go further down the borehole, we go further back in time until we actually get to the moment of the impact about 66 million years ago.
As Ben joins the team drilling down into the rock for evidence of the asteroid's effect, I'm travelling the world to look for clues from fossils. My first stop, 1,700 miles from the crater, is New Jersey. I'm here to see a mass prehistoric graveyard unlike anything that's been unearthed before. This disused quarry may be one of the most important paleontological sites in the world. I'm here to view an intriguing discovery that may directly link the mass extinction to the asteroid impact. There's something very strange about this mass extinction. So many animals died on that day, and yet it's virtually impossible to find casualties of this devastating event. But paleontologists here in New Jersey think they might have found just that, evidence of the day the dinosaurs died. It's such an extraordinary claim. I want to see exactly what they've discovered. I've arranged to meet paleontologist Kenneth Lacavara, one of the most experienced and luckiest fossil hunters in the world. He's going to show me where the discovery was made in what used to be the seabed. We're going back through time.
We are now.
He's going to show me where the discovery was made.
You will be in the Cretaceous.
Excellent. As we descend into the quarry, we arrive at layers of sediment that were deposited during the Cretaceous period, when dinosaurs ruled the Earth.
So down here, we're in the Cretaceous period. Here we are in the Paleogene period after the Cretaceous.
The boundary between the two periods marks the moment that the dinosaurs went extinct 66 million years ago.
So this is the boundary right here. No one in the world has found an in-place dinosaur fossil 1 centimeter above that line.
The team uncovered a dense layer of fossils right at this boundary line. It's potentially a unique discovery.
Dinosaurs? No dinosaurs.
Gosh, that's extraordinary. The animals found here are typical of the late Cretaceous. That's a formidable looking tooth.
It is, isn't it?
Yeah. What's that from?
This is from a mosasaur. Mosasaur is a giant marine reptile, an apex predator. Think of a Komodo dragon that's as long as a bus, with paddles for limbs, a 2-meter jaw packed full of these teeth. We find mosasaurs here below our bone bed, and in the bone bed, we never find mosasaurs above the bone bed because they go extinct along with the dinosaurs.
Ken believes that the mosasaurs he's found here may be some of the last that ever lived, and that they died as part of the Great Extinction event. To understand why, we have to look at the other fossils that Ken has found in the quarry. This is incredible, Ken. Look Look at all those fossils.
25,000 of them.
The way you've laid them out in this grid, is this as you found them?
These are the places in which we found them. Yep, 170 square meters of them.
It's an astonishing amount of work.
All these fossils occur in a layer that's no more than 10 centimeters thick.
For Ken, the first clue that these animals all died in a single catastrophic event is that the skeletons are largely intact, with no teeth marks on them.
They weren't transported, they weren't scavenged, they died suddenly, and they were buried quickly. It tells us that this is a moment in geological time. That's days, weeks, maybe months, but this is not thousands of years, this is not hundreds of thousands of years. This is essentially an instantaneous event.
A second clue comes from the surprising mix of species that had lived in many different environments. I mean, I can pick out large vertebrates.
Sure. We see the occasional bird here. There's a tibia from a crocodile, and that's laying next to a piece of the outer shell of a huge sea turtle, something that would be maybe 1.5 meters across.
And just a few feet away, Ken found another turtle from a different part of the ocean.
This is a coastal living turtle. You can see how tightly articulated it is. This shell doesn't flex. So we know that this turtle didn't dive deeply in the ocean. This animal was living around the coast in the shallow water.
So what do you think you've got here?
All this stuff died suddenly and was buried all at about the same time. So that means all the stuff that comes in from the coast has to come in suddenly. And that tells us that there's environmental disturbance going on the coastline upshore from here. Whatever was the cause, this calamity that wiped out these animals, it was happening in the deep water, it was happening along the coastline, and it's happening on land.
Ken's theory is controversial, but if he's right, this could be the first fossil evidence of a sudden mass death event at the end of the Cretaceous. Right at that point in time when 75% of life on Earth is wiped out. But what caused this mass death event? Could all these animals have been killed by the impact of an asteroid 1,700 miles away in the Gulf of Mexico? Ben is with the scientists who've been drilling into the seabed above the asteroid crater.
I'm here right in the middle of the drilling platform, and there's a fresh core about to come out.
We've already drilled through 500 meters of limestone sediment. Now we're going to start to bring up rock core for the scientists to examine as we get closer to the impact crater.
This is the first full core of the expedition, we're excited to say. The first full 3-meter-long core, some light layers. We're wondering if they're ashes or something, so we're pretty excited.
This, along with other core samples like it, can tell the team so much information about what was going on at the time of the impact.
The first thing the team does with each new core is find out how old the rock is.
Exactly what's living and exactly what fossils we find tell us what age we are.
As soon as the core comes up on deck, we're given a small crumb of material. We take it back to the lab and give an age call within 5 minutes of the core appearing on the deck.
I just got some sweet pictures of this. Look at this crystal. This is the same stuff from the core catcher under the microscope. Look at these crystals.
Though it contains valuable information, this core isn't from the impact crater itself. Instead, it's from the layers of sediment above it. The team needs to drill a further 130 meters down into the sediment to get to the crater itself. The further down they go, the harder the rock is. So that means weeks of 24 hours a day drilling. They want to pull core from an area of the inner crater called the Peak Ring, found only in the largest of supercraters.
They're formed when the massive impact of an asteroid forces rock to erupt in a central uprising, which then collapses outwards to form the distinctive peak ring. It's these rocks that contain the clues to what happened in the moments after impact. It's been 3 weeks since the team started drilling into the seabed, and time and money are running short.
But we didn't sample that because it's in the middle of a core.
The drill is nearly through the hundreds of meters of limestone that has built up since the asteroid struck, approaching rock layers from the day of impact.
Let me look at this in a microscope. I would say somewhere between about 64.5 million years ago and 63.5.
Wow.
So this was E4.
Yep.
Which is 53 million, and now we are 63. So we have 10 million.
Yeah, that sounds like a good estimate. So 10 million years in 3 meters.
In 3 meters.
We've been stuck in the same zone for a while, going forward very slowly, and then all of a sudden, boom, big jump in time.
The team are noticing clues in the latest cores. Something extraordinary.
But as you go down, it's just more and more and more of it. It's got this greenish tint. No, there's one right there. We've now had 4 cores of ever coarsening sands. I think the only process on Earth that can do that's a tsunami.
Tsunamis are huge, turbulent waves that rip material from the seabed. When the wave passes, the material is deposited back on the ocean floor in size order. The heaviest, most coarse sand settles first. The finer sand on top. The thicker the deposit, the bigger the tsunami.
And the fact it's already like 12 meters thick probably already makes it one of the largest, maybe the largest tsunami deposit ever discovered. And if it keeps getting thicker as we go, it will absolutely, unquestionably, be the largest tsunami deposit ever discovered. And of course, it's right here in ground zero and impact.
It's the first major clue of how the impact of this asteroid could have caused a deadly chain of events, starting with the biggest tsunami in history.
1,700 miles away in New Jersey, Ken Lacavara has also picked up evidence of what could have been a tsunami.
After that asteroid hit, it's just chaos on the continent. There are tsunami waves lapping up against the continent. You're going to have trees floating down the estuaries. You're going to have sediment choking the rivers. And that's exactly what we see there. Here in our fossil bed, we get a mixture of marine organisms and organisms that came in from the land. One of our more common fossils is wood.
In the Gulf of Mexico, the crew are on the verge of breaking into the asteroid impact crater. But at the worst possible moment, they've hit a roadblock.
So they just woke me up because there's a problem with the drilling. We don't know if it snapped or if it just got stuck a little bit. We don't know, but they're going to have to bring it back to the surface to take a look.
As they get nearer the crater, the rock is getting tougher to penetrate, and that's causing problems with the drill.
You get to the point where you start pushing the drill beyond its capacity, and right now there's no drilling rods, no bit, no anything in the hole.
While the engineers fix the rig, the scientists lose valuable drilling time.
Behind me, you'll notice the rig is not moving. The pump that allows it to turn has actually broken.
In a bit of a race against time now. Look at the struggle to get to 1,500 meters.
So we're all hopeful, fingers, toes, and so on are crossed, and we'll see how this goes.
Finally, after a month of drilling, the team are pulling rock from the asteroid crater itself. Already they're seeing evidence of the incredible heat generated by the impact. Rock that has melted.
And look at, in this part, it's very clear that we have different kind of colors, like this red color.
It goes from green to red.
I think it's melting material.
Right,
yeah.
I think that is a big cluster melt.
That does too. Look at that. That looks like this wave height.
And we are now fully into impact rocks directly, and it's really easy to see because it's granite, and so you can see these spotted leopard-looking big chunks. So, in effect, these were formed, the days that the dinos died.
Quite heavy, these, aren't they?
Yeah, you really appreciate just how solid this rock is. How deep have you gone with this so far?
We got to just 1330 metres, about that. So we were hoping to get 1500 metres, but we've got 700 metres of peak material, so we're pretty happy.
Why couldn't you get 1500?
Because the budget ran out.
I'm dying to ask a question I've wanted to know as a kid. Where's the asteroid?
Yeah, so a lot of people think I'm going to find the asteroid,
Yeah.
and ask me that question a lot. Something like 95% or more of the asteroid is vaporized. So in fact, there's hardly any asteroids here beneath the surface. The asteroid material has been sort of spread all around the globe, so it's been ejected way above the Earth's atmosphere, travelled around the globe and landed around the Earth.
After 8 weeks, the work here is done.
I don't think it could have gone much better. I'll not forget this place.
It's been an amazing expedition, and I expect we'll have lots more discoveries to come.
More than 300 rock cores have been extracted, which the team hopes will tell the story of how the dinosaurs died. Four months and over 5,000 miles later, the rock cores are now here at the University of Bremen in Germany for the second phase of this colossal and unparalleled scientific journey.
I'm inside a huge fridge that's now home to all the samples that were taken up from the Gulf of Mexico. And it's really cold in here, as you might expect. Now, this is to stop any organisms from growing and contaminating these samples.
This is a test recording. Say something.
Here in Bremen, the research team is working to find out what happened minute by minute after the asteroid struck and what that meant for the dinosaurs.
Okay, this is day 2 that we've had samples, and I'm going to take you through around the labs where everybody started their analysis. Over here we can see people looking through microscopes, looking at thin slides that have been collected from offshore.
All right, Philippe, I'm going to film you while you take a look at this core.
Hey.
Unravelling these cores is a mammoth task. Over 800 meters of rock has to be carefully split, tested, and photographed. But what they're starting to reveal about the force of the impact is literally earth-shattering. This core from above the crater is what typical geology looks like. Layer upon layer of similar-looking rock laid down on the seabed very slowly. This 3 meters of limestone took millions of years to accumulate. But when the asteroid struck, it was geology at hyperspeed. The next 600 meters of rock were deposited in a single day, leaving a unique and chaotic jumble.
Sean, I mean, how do you make sense of this incredible place that you've got here?
It is amazing. This is 150 kilometers worth of core collected by the International Ocean Discovery Program and all its predecessors back to the late 60s.
Mm-hmm.
But of all these cores, the most amazing is the one we just collected in the Chicxulub impact crater.
Of course, yeah.
You can see this black flowing texture of a rock. This is actually, it looks like it flowed, right? You can see textures in it. This is actually melted basement rock, melted granite. And it takes amazing pressures to do that, and amazing pressures to melt the rock. This is, so I've got a piece of what would be considered sort of normal granite, if you will, the kind that you might put on your countertop. And that's why we use it, because it's nice and hard. I mean, right?
Pretty solid.
Yeah, exactly. This stuff has actually seen shock
of an incredible level. So think of it as pressure waves moving down through the granite, like lots and lots of little earthquakes going. And what it's done to it is all the way down at the scale of a crystal, is it's actually deformed it so that the final granite can be broken.
It just crumbled up. That's amazing. Oh, wow. Just such incredible, amazing forces at work here. This whole event, I'm still finding it difficult.
Well, even as a geophysicist, when we study this for a living, it's really hard to wrap our brains around the enormity of the pressures involved, the enormity of the destruction that happens in the middle of an impact, and so quickly. I mean, this all happened in less than 10 minutes.
It's becoming clear just how mind-bogglingly huge the Yucatan impact really was. And to help grasp its scale, Sean is taking a trip to a more recent impact site in Arizona.
This simple crater here was created by about a 50-meter or 150-foot asteroid impacting the Earth about 50,000 years ago. It's about a mile across. It's actually quite small. It's basically simply a bowl-shaped crater. Everything above the red line that you see there is actually material that used to be buried and has been flipped up on end and is now, or flipped up upside down, and is now laying as a pile of broken up material.
By studying the shape of the crater and the upheaval of the rock layers, Sean, Joe and the team can compare this site to the Yucatan impact zone. Even a small asteroid strike like this would have had dramatic consequences.
So it comes in at something like 26,000 miles per hour. 10 kilometers away from here, we would have a fireball reaching. Maybe 20 kilometers away from here, a shock wave. And say 40 kilometers away from here, hurricane force winds. But that would just have been a bad day in today, northern Arizona.
So this is what a 50-meter wide asteroid can do. It's devastating, but localized. But what about an asteroid that's 9 miles across and leaves a crater 120 miles wide? To understand the effects of that impact, the team needs to know exactly how much energy it released. To do that, they're comparing rock samples from Yucatan to data gathered from some of the largest ever man-made explosions. This is the Nevada test site, the most bombed place in the world. The US military have detonated 904 atomic bombs here. To help us understand how atomic bombs connect to asteroids, we've enlisted the help of physicists Mark Boslow and David Dearborn.
The blast must have come all the way through, and I bet these windows blew out. Those shards of glass would be accelerated by 90-mile-an-hour winds.
The windows were gone.
They're totally boom.
This house was part of a test village called Survival Town, built to study the effects of a nuclear blast. It actually survived a blast called Apple II in May 1965.
Most of the damage is done by the fireball and the heat that is generated, or the blast wave as it goes by. And the houses that were in closer didn't survive.
Those of us who work on asteroid impacts, we naturally started comparing them to nuclear explosions. It's a similar phenomenon. The experimenters had high-speed cameras. They had gauges that measured the intensity of the shock wave, the blast wave in the air.
The tests found that nuclear explosions are devastating even at a microscopic level, causing catastrophic shock to minerals such as quartz.
The pressure is so high in a shock wave from a nuclear explosion that it actually exceeds the strength of a crystal. Crystal is made up of a uniform array of atoms, and that uniformity is completely disrupted by a strong shock wave, and that's what shocked quartz is.
In Bremen, Professor Joanna Morgan is looking at quartz found in rock cores from the asteroid impact site. From nuclear test data, she knows exactly how much force it takes to shock quartz. From this, she can tell how much force the Yucatan rock has been subjected to and begin to calculate the exact amount of energy released when the asteroid struck.
So this is a piece of shock quartz that we recently drilled from the Chicxulub impact crater. There's lots of lines here. Essentially, the more lines we have on the screen, different directions, the more shocked this rock has been. These are caused by the impact, by the shock wave that travels through this piece of quartz. So we use exactly the same hydrocodes, they're called, to model nuclear explosions as we do to model impact craters. We've actually stolen these codes and applied them to our simulations of impact crater formation.
What sort of force were we actually talking about from the asteroid hitting it?
This event was equivalent to about 10 billion Hiroshimas. So absolutely enormous, the most dramatic event in the last 100 million years.
10 billion Hiroshimas combined. That's the amount of force going into this. It's incredible, it really is.
Finally, we have hard evidence of just how powerful the asteroid strike really was. 10 billion Hiroshimas. It's a major revelation.
But the truly incredible thing about this asteroid strike was that it changed the face of our planet within seconds.
And now we know that, we can do something that has never been done before. Create a simulation of exactly how the impact affected Earth and the dinosaurs.
Here's what the new results tell us about those crucial initial minutes after the asteroid struck.
The asteroid, 9 miles wide, smashes into the Yucatan at 40,000 miles per hour. Vaporizing instantly. The impact makes a hole in the Earth 20 miles deep and 120 miles across, turning the surrounding sea to steam and shattering the Earth below. Rock from deep in the Earth's crust then rises miles into the air, forming a tower higher than the Himalayas that collapses to form a strange ring of peaks that exists today. All this in the first 10 minutes.
What did this mean for the dinosaurs? Well, it started an unstoppable and devastating chain of events.
First, like an enormous nuclear explosion, a radiation fireball 10,000 degrees centigrade spreads out from the impact zone. This searing hot sphere fries everything within a 600-mile radius in an instant.
The truly global devastation had its roots not in the blast, but in the huge vapor plume that rose out of the crater and through the atmosphere.
A red-hot cloud of vaporized asteroid and rock, expanding upwards 600 miles, spreading rapidly outwards to fill the planet's atmosphere.
Back then, faraway New Jersey was covered in ocean. And it too would soon feel the effects of the impact. 1,700 miles from the site of the impact, the fireball wouldn't have been visible. That blazing, towering, swirling cloud would have been just over the horizon, but we might have seen a faint glow. The animals here were safe from the direct radiation. 2.5 hours later, like the sound of heavy traffic in the distance, the shock wave, now a sound wave, arrived. Wind starts to whip up, growing stronger and stronger until we're facing into hurricane-force winds. The blast wave from the impact surged across the Earth at enormous speed. Its effects would have been short-lived. But those few traumatic hours left an indelible impression in the Earth's geological record.
These are beads of molten rock that rain down from the skies, and as they cool, they become glass. And if you melt rock and you cool it fast, it doesn't have a chance to turn back into rock. It forms glass called spherules. And we find these little spherules right here in this mass death assemblage.
What produces the kind of energy and heat needed to form these spherules then?
Well, when you have an asteroid impact, it melts the rock and it flies up through the atmosphere, and these bits of molten rock rain down on the planet.
These 66-million-year-old droplets of molten rock show that debris was falling on landscapes far away from the impact zone itself. Protected by the water, marine creatures like the mosasaurs may have been able to survive these immediate effects. But for the dinosaurs on land with nowhere to hide, this was the beginning of the end. To show how the effects might have played out for dinosaurs on the ground, we've enlisted paleontologist Steve Brusati and Tom Williamson to our international team. They've come to New Mexico, 1,200 miles from the impact zone, hunting for remains in one of the richest dinosaur fossil sites in the world.
Yeah, okay.
Whoa.
Got a bone layer.
Check this out.
A lot of times we'll just be walking around in the Badlands looking for stuff that's sticking out of the rock. That's always the first clue. This one's really sticking out. We can tell from the shape of it that it's part of the backbone of a dinosaur.
It's a bone from the backbone of a horned dinosaur. This is probably Pentaceratops, which means 5-horned face, 2 brow horns, a nasal horn, and then a cheek horn on each side.
Triceratops has 3 horns on his face. This guy had 2 more horns, so 5 horns total, so an even gaudier dinosaur.
The ceratopsians, like Pentaceratops and Triceratops, were a large group of plant-eating dinosaurs that roamed the American landscape for the 20 million years leading up to the asteroid impact.
There it is.
Pretty good. Look at that.
Not bad.
This whole area here is, honestly, is littered with these kind of bones. These were the cows of the Cretaceous. They would have been everywhere on this landscape.
66 million years ago, this area would have looked very different. Today it's known as the San Juan Badlands. Back then, it wasn't so bad at all. This whole area was a lush jungle. Dense vegetation, thick forests cut through by flowing rivers.
When that day started, this whole area here would have been teeming with dinosaurs. And then, about 2,000 kilometers or so, 1,200 miles in this direction to the southeast, the asteroid hit. And very quickly, the dinosaurs would have realized that something was wrong, because there would have been an enormous red glowing cloud that would have filled up much of the sky here.
The glowing cloud would have looked dramatic, but this far from the impact zone, the dinosaurs here would have been safe for now.
Now their cousins down in Texas, about 1,000 kilometers closer to the impact site, they were toast. They were incinerated, they were vaporized.
By studying the Yucatan rock core, we know the exact timing of what happened next. 11 minutes after the impact, the vapor cloud arrived in New Mexico. The skies darkened, and the temperature started to rise.
It wasn't really a case of fire and brimstone raining down from the heavens. It was more a case of all of that stuff heating up the atmosphere and turn the atmosphere into a giant radiator.
heat was so intense that over 1,000 miles away from the impact, many animals would have been roasted alive. Climate specialist Dr. Brian Toon is the first scientist ever to theorise what happened next. A devastating global firestorm he's studied for more than 20 years.
It wasn't falling on you, it was 60 kilometers above the ground or so, and the glowing hot lava was emitting an amount of energy that's a few times larger than the sun. This is not a normal fire. The fire was started everywhere, which causes what's called a mass fire. Mass fires can be much hotter than a normal fire. All the leaves on the ground caught fire, the leaves on the trees caught fire, the underbrush caught fire. There's winds at hurricane speeds rushing into the fire, drawn upward into the rising flames, and they consume everything. And this vapor quickly spread across the planet. It probably only took a few hours for it to reach the farthest reaches of the Earth.
Thanks to our new model of what happened after the impact, we now know that fires spread right around the globe. But were these fires devastating enough to cause the extinction of all of the world's dinosaurs in a single day? To find out, I'm travelling far from the impact site to the very tip of South America and the remote wilderness of Patagonia. Over 4,000 miles away from where the asteroid hit. I am all the way down here in Chile. Now, we tend to think of this asteroid as being absolutely enormous, and it was 14 kilometres in diameter, but in the context of the size of the Earth, that's like a grain of sand impacting on a bowling ball. And I want to understand what kind of impact the asteroid landing here had on the dinosaurs right down here at the toe of South America. Leading the hunt for clues is paleontologist Marcelo Lepe. He's taking me to look for dinosaur remains in a mountain valley that's best accessed on 4 legs. Marcelo, can you explain to me how the geology of this valley works?
Actually, we are passing through time. And we are moving to the end of the Cretaceous, to the end of the age of the dinosaurs. We are at the moment in 80 million years ago. This is Campanian.
So this is fantastic. As we ride along the valley, as we ride north, we're riding from 80 to 66 million years.
Through time.
Getting closer to that extinction event. We've reached the Valley of the Dinosaurs. Now I want to see what sort of dinosaurs lived here and find out what happened to them in the hours after the impact. So should we get off and have a look?
Yeah, let's leave the horses and look.
Seems like a good idea.
The place is literally full of bones. As you can see, this sunlight is the best because the angular light is reflecting the bones.
Let's see if we can find a dinosaur then.
Yeah, let's see. Oh, for example, there. Or here.
These.
Look, just beside you.
This here?
Yes, it's a dinosaur bone.
Oh,
no.
That's fantastic.
The different color is
it's really
grayish or white.
Yeah. So what's that then?
Oh, it looks like a vertebrae. Probably the first one.
Okay, so yeah, so that looks like a facet. It looks like the surface of a joint, and that would be where the skull sits. Any ideas what species?
Yeah, probably an hadrosaur, 99%.
Really?
Yeah, it's your first hadrosaur, yeah?
Yeah, it is. This valley is now a bone bed 4 miles long. Yes, that is a bit of fossilised bone. And they're everywhere, scattered across this hillside. It's just extraordinary. Once it was home to herds of hadrosaurs. Plant eaters up to 30 feet long with a distinctive duck-billed face. But did the dinosaurs down in Patagonia die on the day the asteroid hit? Thanks to the team in Bremen, we now know that once the asteroid struck the Yucatan Peninsula, over 4,000 miles away, it took 42 minutes for the superheated cloud of debris to reach Patagonia. For much of the planet, the fires triggered by the burning sky led to total destruction. But Marcelo has found evidence that that may not have been the story here. Plants that the hadrosaurs used to eat.
This is Nothofagus, the southern beach.
They're all around here, aren't they?
If you want to see it, look at that architecture. And I want to show you also this one. This is from Las Chinas, the same valley we were looking for the hadrosaurs.
Oh, this is fantastic. This is what the hadrosaurs were walking on.
Yeah, and if you want to compare it...
Well, that looks incredibly similar. Is there actually a relationship between this fossil leaf and this living one?
Oh, there is a direct line from this fossil and this one that is living today in Patagonia.
So this is fantastic evidence that down here in Patagonia, some species did actually make it through. 66 million years ago, this region was warm, wet and dense with vegetation, like the southern beach. A species of plant that survived the fires on impact day. And if plants survived, maybe the dinosaurs here could have done too. Life down here should have been badly hit. But the fossil evidence, particularly of plant life, is telling us a different story. That the immediate fallout from Chicxulub in Patagonia was not as bad as predicted. So perhaps our hadrosaurs had a stay of execution. Maybe they made it through that first day. But something got them in the end.
To determine exactly what did happen in the days, weeks and months after the asteroid struck, the Bremen team is still hard at work studying rock samples from the impact crater. Dr. Philippe Claes thinks he's found, perhaps, the most important clue yet.
So, Philippe, when this asteroid struck Earth, it had a massive and devastating impact, but that didn't quite seal the fate of the dinosaurs, did it?
Probably not. Remember, the dinosaurs were ideally adapted to the late Cretaceous environment. They were the ultimate animal for the Cretaceous. What happened here is that we have an incredible change in the Earth system. Basically, kills a dinosaur everywhere on Earth. In Africa, Antarctica, in the forest or in the savannah.
But what made them extinct? Because you talk about a global scale suddenly. What went global? What happened
What
across the
went
world?
global is really the ejection of material from the crater. Look at what I have in my pocket. This is gypsum.
Right, okay.
This was part of Yucatan at the time of impact.
Yeah.
Okay? And this material here contains sulfates. And this gypsum, okay, affects the chemistry of the atmosphere. It changes it drastically.
This area is meant to be rich in this sort of stuff.
It's supposed to be full of it, okay? But it's not. We can look for the remnants of it here. In the core, it's totally absent, which means that almost the entire sequence of gypsum that was present in the sedimentary target at the time of impact went into the atmosphere.
This is a huge discovery. The presence of gypsum means the plume of vaporized rock that spread across the world was dense with sulfates that block sunlight. The same thing happened after the 1991 eruption of Mount Pinatubo in the Philippines. Sulfates reduced the amount of sunlight reaching land by 10%, which caused a drop in global temperatures.
25 years ago, Pinatubo had an incredible effect on the atmosphere. It cooled it by, very little, but it had an effect, and it stayed for a couple of years.
Right.
Here we have an event that is orders of magnitude more important. Pinatubo is nothing compared to the Chicxulub impact. It's really going global. No places is protected. No dinosaur can escape the consequence of the Chicxulub impact. This is this gypsum. This is what killed the dinosaurs.
This astonishing find is the final piece of the jigsaw, allowing us for the first time to model what finally killed the dinosaurs.
It's what happened in the days after the impact that made it a global extinction. Our blue planet turned grey.
Long after the hot skies cooled, ash and dust in the atmosphere almost completely blocked out the sun. As the lights went out, global temperatures plunged more than 10 degrees centigrade within days. This is where we get to the great irony of the story. Because in the end, it wasn't the size of the asteroid, the scale of the blast, or even its global reach that made dinosaurs extinct. It was where the impact happened.
Had the asteroid struck a few moments earlier, or maybe even a couple of seconds later, then rather than hitting shallow coastal waters, it might have hit deep ocean.
An impact in the nearby Atlantic or Pacific Oceans would have meant much less vaporized rock, including the deadly gypsum. The cloud would have been less dense, and sunlight could still have reached the planet's surface, meaning what happened next might have been avoided.
In this cold, dark world, food ran out in the oceans within a week, and shortly after, on land also. With nothing to eat anywhere on the planet, the mighty dinosaurs stood little chance of survival.
In Patagonia, 10% of plant species went extinct. The southern beaches would have shed their leaves, shutting down for the long winter that the asteroids set off. The hadrosaurs were left to starve. The demise of the dinosaurs down here in Patagonia was nowhere near as dramatic as being obliterated by a blast wave or drowned in a tsunami, or even being caught up in a colossal forest fire, but they were doomed nonetheless. The dinosaurs as a group were hugely successful and diverse and have been on the planet for more than 150 million years. But this Chicxulub event was more than just a local phenomenon. It changed the climate globally, plunging the world into a deep, deep winter, and there was no time to adapt. So in some ways, the dinosaurs that died instantaneously were the lucky ones. This sudden climate change may finally solve the mystery of what happened in New Jersey. As the food supply in the oceans dwindled, shallow water creatures roamed ever deeper. But eventually, the food would run out. And all of these animals from different parts of the ocean died, coming to rest in a single layer.
It's been an incredible adventure, decades in the planning. A multi-million-pound scientific expedition weeks of drilling rock samples from deep inside a supercrater, and months of studying hundreds of meters of rock samples.
So this was E4.
Yep.
Which is 53 million to 55? We were just jazzed about the science all day long. Many people have been up for 20 hours and they were still just going with enthusiasm, describing the cores, looking at the microfossils. It was a heady experience.
All that hard work has paid off in a big way. The team has been able to reveal extraordinary new details, evidence about how the dinosaurs died. But perhaps even more astonishing than what killed the dinosaurs is what happened after they were gone.
The asteroid and its aftermath ended the age of the dinosaurs. But as the clouds started to clear, months or years later, the dormant plants came back to life. And a tiny group of animals came out of hiding to inherit the Earth. Creatures that would, over millions of years, evolve into a huge range of different species, including us.
On the tip of my finger right here is a lower tooth of something called Mesodma. There's a little guy who's probably about the size of a mouse. This is one tough little mammal, one of the very few species known to survive through the global devastation. It's a blade-like tooth. It was able to feed on things like insects and seeds, so it didn't have to rely on photosynthesis.
Mammals had lived in the shadow of the dinosaurs for 100 million years, but now it was their turn. This chance event that was the doom of the dinosaurs was a stroke of luck for the surviving mammals. With the dinosaurs gone, suddenly the landscape was empty of competitors and ripe with possibilities. Just 500,000 years after the extinction of the dinosaurs, and landscapes around the globe had filled up with mammals of all shapes and sizes. Fast forward another 60 million years or so, and we have the evolution of an extraordinary upright walking ape that contemplates its own existence and the demise of ancient creatures they'd never even seen. Chances are, if it wasn't for that asteroid, we wouldn't be here to tell the story today.
Mackenzie Crook and Toby Jones are not metal detectors, they're metal detectorists. Comedy next on 2. And charting his rise and fall, the story of O.J. Simpson continues. The compelling Made in America is on BBC 4.